Alright, we're going to begin a short unit on direct variation and compare that with inverse variation. But today we are going to learn the equation of direct variation, what the graph would look like, and how could it be applied. So the equation of direct variation is y equals k times x. Now this k is a number, and this is called the constant of variation. Now what this is saying to you is that y is defined by some multiple times its x value. And this is read, y varies directly as x. Or y is directly proportional to x. So that's the equation of a direct variation. Let's see what the graph of a direct variation would look like. And now, you should be familiar with what this looks like. If I plug in a number here, y equals some number times x, well, that is a linear equation. So the graph of a direct variation just looks like that. It's a linear equation which passes through the origin with the slope. So that means it can't be a zero slope and it can't be an undefined slope. It has to have some kind of a slope, and this is direct variation. It is a function because it passes the vertical line test. It's also a one-to-one function because it passes the horizontal line test. So here's an example of a direct variation graph. So in this case, we have y varying directly as x, where the constant of variation is 2. This is what the graph would look like. If you take a look at the ordered pairs, now this would be given to you at the equation. What would the graph of y equals 2x look like? Well, that's a linear equation passing through the origin with a slope of 2. So rise 2, run 1, rise 2, run 1, rise 2, run 1. And here is a corresponding table of values. Let's see what's going on with the y values here. The constant of variation here is 2, so that's just telling you that's the slope of the graph. That's how all of your y values are changing. So if we take a look at the y values, it's going from 0, 2, 4, 6, 8. This is linear growth at a rate of 2 every y value. So every time I move up another y value, I increase by 2. So here's a table of values, and we could see what is the constant of variation, and hence the equation of the direct variation. Then we're going to graph the direct variation. So here's a table of values. Our y values, for every x value that we're increasing x values by 1. So there's no trickery going on here. But if we look at the y values, 0, 4, 8, 12, 16, we're going up by 4 each time. Therefore, our constant of variation is 4. And hence, our equation, y equals 4x. So we're passing through the origin with a slope of 4. Rise 4, run 1. Rise 4, run 1. And there is our graph. So now we're familiar with the equation of direct variation. We're familiar with the graph of direct variation. Let's work on some application. Okay, so here's a word problem. Y varies directly as x. If the value of y is 4 when x is 1, what's the value of y when x is 3? So now, y varies directly as x is our cue to say, I know that y equals some number k times x. And in these conditions, they're giving you a case 1, y is 4 when x is 1, and a case 2. we're going to use case 1 to determine the value of k. Then we're going to use case 2, knowing the value of k. So let's use case 1, y is 4 when x is 1, and plug it into our equation. So y is 4 when x is 1. So, solve, and now we know k equals 4. So we don't have to be so ambiguous about our direct variation formula. Now we can say, I know y equals 4x. That's our direct variation formula, because this is a constant of variation, meaning it's constantly 4, regardless of the situation, regardless of the values of x and y. So now the second condition told us, what's the value of y when x is 3? So y equals 4 times 3, so y equals 12. Another way we could do this, they gave us x1 and y1. We're looking for either an x2 or a y2. They told us that y1 was 4 and x1 is 1. They want to know what's the value of y, I don't know, when x is 3. So we can see, what happened to my x terms here? Well, my x terms tripled. Therefore, my y terms will triple. Here's another example. Y varies directly as x. Here's my cue. Y varies directly as x. If the value of y is 3 when x is 2, what's the value of x when y is 1? So let's plug in our first condition. The first condition, y is 3, x is 2. 3 equals k times 2. Solve for k. So now we know k equals 3 over 2. So we don't have to be so ambiguous about our formula. We could say y equals, I know k is 3 over 2, times some value x. Second condition, what's the value of x when y equals 1? So plug in 1 equals 3 over 2x. And now we solve for x. Multiply each side by the reciprocal of 3 over 2. So I'm going to multiply by 2 over 3. Giving us 2/3 equals x. Let's take a look at this another way. They gave us x1 and y1. We're looking for either x2 or y2. y1 was 3 and x1 was 2. What's the value of x? I don't know what x2 is when y is 1. So now we can take a look at what happened to our y terms. Just like before, we said what happens to our two x terms. We were given two x terms. We multiplied x1 by 3, therefore we multiply y1 by 3. And in this case, they gave us two y terms. What happened to get from y1 to y2? We divided by 3. So what do we do to get from x1 to x2? We divide by 3. 2 over 3 is 2 over 3.